Hi, in this screencast we are going to look at accuracy and precision and how we use a calculation called percentage error to report the accuracy of a lab. So accuracy refers to the closeness of a measurement to the correct or the actual or the accepted value. Precision refers to the closeness of a set of measurements of the same quantity made in the same way. So in general, accuracy refers to a comparison of your data with what the actual or accepted value is. Precision deals with how close all of your measurements are to each other. So precision and accuracy can go together or they don't have to. So let's look at some examples here. In this target, if we're aiming for the bullseye and all of our darts are clumped together here, then we're precise because all of our darts are together, but we're not accurate because we were aiming for the bullseye and we did not hit what we were aiming for. So we have precision, but not accuracy. In the next example, if we're still aiming for the bullseye, we can see that our darts are all in the vicinity of the bullseye, but they're not really grouped together. So we were accurate because we're pretty close to the bullseye, but we were not precise because our marks are made all over the place. In this third example, again, if we're still aiming for the bullseye, none of our darts really made it to the bullseye, and none of them are really close to each other either. So we're not accurate, and we're also not precise. Finally, in the last example, if we're aiming for the bullseye, we can see that all of our darts hit or are clumped together near the bullseye. So we are accurate because we hit what we were aiming for, and we are precise because they're all grouped together. So again, accuracy deals with how close you are to the actual value, whereas precision deals with how close all of your measurements are to each other. So we report our accuracy for an experiment using a calculation called percentage error. Percentage error is calculating by subtracting the accepted value from the experimental value and then dividing the difference by the accepted value and then multiplying it by 100. So that's just a really wordy way of describing this equation. So we're taking the experimental value minus the accepted value. We take that answer divided by the accepted value and then multiplied by 100. Now, what this doesn't show you is that the experimental value minus accepted value will always be an absolute value. That's how you oftentimes see the equation written. So percentage error is always expressed as a positive quantity. So if you take the experimental value minus the accepted value and you have a negative number, you ignore that negative. So percentage error is always positive. Let's look at a sample problem. A student measures the mass and volume of a substance and calculates its density as 1.4 grams per milliliter. The correct or accepted value of the density is 1.30 grams per milliliter. What is the percentage error of the student's measurement? So using our equation, we're going to take our experimental value minus our accepted value. So our experimental value that we calculated was 1.4 grams per milliliter. Our accepted value, which was the correct value, is 1.30 grams per milliliter. I'm going to divide that by my accepted value, which is the 1.30 grams per milliliter, and then I multiply it by 100 to make it a percent. So my percent error is 7.7%. You will be responsible for completing this calculation when we do labs and so forth in class, and we'll be practicing with this some more tomorrow. Please make sure that all of your notes are as accurate as possible and complete the worksheet on accuracy and precision that was provided for you by Mrs. Benke in class. Submit your notes and your worksheet to Mrs. Benke next class period.